AI chips may look like tiny pieces of metal and silicon, but they are among the most advanced products ever manufactured. The journey begins with raw quartz and silica sand. Inside a high-tech refining facility, these materials are heated, purified, and transformed into electronic-grade silicon. The purified silicon is melted inside a crystal growth furnace. A seed crystal is lowered into the molten material, and slowly a large single crystal silicon ingot is pulled upward. This ingot becomes the foundation of the chip.
Surface looks pristine, no visible defects. Agreed, the crystal structure is uniform. Support cradle is secure, no movement. Excellent, log the data, it's ready.
Initiating end trims now. Dust extraction is active, flow is optimal. Cuts are clean, monitoring complete.
Next, the ingot is trimmed, ground, and sliced into thin circular wafers using diamond wire saws. Each wafer is polished until the surface becomes mirror smooth and flawless. From here, the wafers enter the clean room. Inside this sterile environment, even a tiny dust particle can destroy a chip. Robotic systems move the wafers between machines while technicians monitor the process in full cleanroom suits. The wafer is cleaned, dried, and prepared for its first layers. A thin oxide layer forms on the surface, then photoresist is applied. The wafer spins at high speed, spreading the light-sensitive coating into a perfectly even film. Now comes lithography. Inside an advanced EUV scanner, powerful light projects microscopic circuit patterns onto the wafer. These patterns are so small they cannot be seen with the human eye. After exposure, the wafer enters development, where the hidden pattern appears. Then plasma etching begins. Blue-purple plasma carves the pattern into the wafer with extreme precision. Temporary photoresist is stripped away, and the wafer is cleaned again for the next stage. The chip's electrical behavior is then engineered through ion implantation. Ions are directed into selected areas of the wafer, changing how the silicon conducts electricity. After annealing, these regions are activated and stabilized. Layer by layer, the transistors begin to form. Thin films are deposited, patterns are exposed, structures are etched, contacts are opened, conductive materials are added. The wafer is polished again and again to keep every surface flat. At microscopic scale, billions of transistors are being built. But transistors alone are not enough. They must be connected. Metal interconnect layers are created above the transistor layer. Copper and other conductive materials fill tiny trenches, forming dense wiring networks that carry data and power across the chip. This process repeats many times, creating stacked layers of microscopic circuits. Throughout production, inspection systems scan the wafers constantly. Optical tools, electron beam systems, and metrology equipment check for defects, misalignment, thickness errors, and pattern damage. only wafers that meet strict standards move forward. Once fabrication is complete, the wafer enters electrical testing. Tiny probe needles touch each chip area to check which dies work correctly. The wafer is then thinned, mounted onto dicing tape, and cut into individual AI chip dies. Robotic tools pick the good dies and move them into advanced packaging. For powerful AI chips, packaging is critical. The chip die is placed onto an interposer with microscopic precision. High bandwidth memory stacks are positioned nearby to provide fast data access.
This batch has higher defect density.
Right. Check the uniformity on the data screens. Layer 2 thickness is within spec.
Good. Let's run a full overlay check.
Micro bumps connect the chip, memory, and interposer into one advanced package. The package goes through bonding, underfill, curing, X-ray inspection, and optical inspection to make sure every hidden connection is secure.
Initiating X-ray inspection of the AI chip package. Scanning for hidden solder joint defects. Analyzing alignment, defect detected. Inspection complete. Defects logged.
Next, thermal materials and a heat spreader are added. AI chips generate intense heat, so cooling performance is essential. The completed chip package is tested for power, memory, signal quality, speed, and thermal behavior. Approved chips are sorted, then mounted onto accelerator boards. Additional components, connectors, power modules, and cooling hardware are installed around the chip. The finished boards enter system-level testing inside server racks.
Okay, initiating validation. Looks good. Installing the board now. Great, monitoring the metrics. Board is seated, lights are on.
Cart 7, proceed to Bay 3.
Confirm, moving now.
All shipments on schedule.
If you're enjoying this look inside the world of AI chip manufacturing, hit the like button, subscribe to the channel, and turn on notifications for more high-tech factory process videos.